Welcome to Review Central's Mathematics Proficiency Reviewer Drills, featuring drill questions on trigonometric ratios. Mathematics proficiency is a typical subtest in many exams, including most scholastic admission and scholarship qualifying tests, some professional licensure and certification exams, and even some employment pre-qualifiers. If you are eyeing or are set to take any of these tests, then this reviewer is intended for you. There are 11 carefully curated questions featured on this reviewer. All questions are modeled on actual questions that appeared on various mathematics proficiency subtests. Before we proceed, don't forget to subscribe to Review Central and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Let's begin. Drill question number 1. Which trigonometric ratio or ratios cannot be equal to or greater than 1? 1. Sine. 2. Cosine. 3. Tangent. 4. Secant. 5. Cosecant. 6. Cotangent. Your answer choices are A. 1 only. B. 3 only. C. 5 only. D. Both 1 and 2. E. 1, 2, and 3. The correct answer is D. Both 1 and 2. Let's refer to our basic trigonometric triangle, as shown. With a simple analysis of the triangle, we should arrive at these conclusions. The trigonometric ratios sine and cosine never equal or exceed 1, because the hypotenuse, that is, the longest side of a right triangle, is always their denominator. The trigonometric ratio tangent can be less than, equal to, or greater than 1, because the hypotenuse is never its denominator. The trigonometric ratios cosecant and secant are just the reciprocals of sine and cosine respectively. Therefore, they are always more than 1 because the hypotenuse is always their numerator. The trigonometric ratio cotangent, on the other hand, is the reciprocal of tangent. Like tangent, it can be less than, equal to, or greater than 1. Going back to our given question above, you should have determined by now that the correct answer is D, sine and cosine. If you know even just the basics of your trigonometric ratios, then you probably didn't have any problem answering this question. In fact, you might have found it too easy. But mind you, this question was modeled on an actual question that appeared in the University of the Philippines College Admission Test or UPCAT. Let's take this opportunity to quickly review the sohcahtoa rule of trigonometric ratios. Let's use the same basic trigonometric triangle we used earlier. As you are most probably already aware of, sohcahtoa is a very handy acronym to help recall the trigonometric ratios. So stands for sine is opposite over hypotenuse. Ca stands for cosine is adjacent over hypotenuse. And toa stands for tangent is opposite over adjacent. Remember sohcahtoa and you'll never forget your 6 trigonometric ratios ever again. But wait, how come the acronym only defines sine, cosine, and tangent? What about the other 3 trigonometric ratios, cosecant, secant, and cotangent? We only need to memorize the first 3, sine, cosine, and tangent. Cosecant, secant, and cotangents are simply reciprocals of the first 3 respectively. Take note that trigonometric ratios work only with right triangles. Keep this in mind because in many cases a given triangle may not be a right triangle, and we will need to undergo some preliminary steps to derive right triangles from it before we can apply our trigonometric ratios. And here's a Review Central pro tip for you. When solving trigonometric ratios, it always helps to draw your triangle and indicate the given values accordingly, if an illustration is not provided in the question, that is.
Drill question number 2. Sine 30 degrees is given as 1/2. What is cosine 30 degrees? A. 2. B. 2 over square root of 3. C. Square root of 3. D. Square root of 3 over 2. E. 1 over square root of 3. The correct answer is D. Square root of 3 over 2. Sine 30 degrees is given as 1/2, or 1 over 2. From sohcahtoa we know that sine is opposite over hypotenuse. This means that we are dealing with a right triangle whose opposite side and hypotenuse has a 1:2 ratio. Let's draw this triangle for now. We are looking for cosine 30 degrees. From sohcahtoa, cosine is adjacent over hypotenuse. Therefore, we need to know what the length of the adjacent side is. Given that the hypotenuse is 2 and the opposite side is 1, we can compute for the adjacent side using Pythagorean formula, and arrive at square root of 3. Actually, this was already hinted to us in the answer choices, but it is always good to verify it ourselves. With the length of adjacent side now known, it is just a matter of going back to sohcahtoa to establish that cosine 30 degrees is equal to square root of 3 over 2.
Drill question number 3. Given that cosecant 30 degrees is equal to 2, find tangent 60 degrees. A. 2. B. 2 over square root of 3. C. Square root of 3. D. Square root of 3 over 2. E. 1 over square root of 3. The correct answer is C. Square root of 3. Cosecant 30 degrees is given as 2, we can actually express this as 2 over 1. From sohcahtoa we know that cosecant is hypotenuse over opposite, or the reciprocal of sine. This means that we are dealing with a right triangle whose hypotenuse and opposite side has a 2:1 ratio. Let's draw this triangle for now. Notice anything? That's right, it's the same triangle as that in drill question number 2. Same as in drill question 2, given that the hypotenuse is 2 and the opposite side is 1, we can compute for the adjacent side using Pythagorean formula, and arrive at square root of 3. Again, this was already hinted to us in the answer choices, but it is always good to verify it ourselves. We are looking for tangent 60 degrees. Our given angle, however, is 30 degrees. Recall that the internal angles of any triangle sum up to 180 degrees. Since we are dealing with a right triangle whose other angle is 30 degrees, the third angle should therefore be 60 degrees. Using our sohcahtoa rule, and from the perspective of the 60-degree angle, tangent 60 degrees should be square root of 3, that is, the opposite side, over 1, the adjacent side. We simplify this to just square root of 3, our correct answer.
Drill question number 4. The escalator at the Auti gas station of MRT near the Asian Development Bank along Idsa rises 76 feet at a 30-degree angle as shown in the diagram. Find the distance x a person travels on the escalator. A. 152 feet. B. 125 feet. C. 263.3 feet. D. 62.4 feet. E. Insufficient info to determine distance x. The correct answer is A. 152 feet. To find the distance x a person travels on the escalator, we can write a trigonometric ratio that involves a side with an unknown length x, another side with a known length of 76 feet, and a known angle of 30 degrees. In our given 30-degree right triangle, x is the hypotenuse and the height of 76 feet is the opposite side. What trigonometric ratio can we use in this case? That's right, we can use either sine or cosecant, because we are dealing with the opposite side and the hypotenuse. Let's use sine. Sine 30 degrees equals 76 over x. Next step is to find x. Multiplying both sides by x, we'll get x sine 30 equals 76. But recall from our previous drill questions that sine 30 degrees is equal to 1 over 2. Take note that regardless of the actual lengths of the sides of a right triangle, as long as one of its angle is 30 degrees, sine 30 degrees can be simplified to 1 over 2. From here, we can replace sine 30 degrees with 1 over 2. Therefore, x is 152 feet. The person travels 152 feet in the escalator of MRT Auti gas station.
Drill question number 5. Jeremy is measuring the height of a pine tree in Baguio City. He stands 45 feet from the base of the tree. He measures the angle of elevation from where he is standing on the ground to the top of the tree to be approximately 60 degrees. How tall is the pine tree? A. Approximately 90 feet. B. Approximately 45 feet. C. Approximately 45 over square root of 3 feet. D. Approximately square root of 3 over 45 feet. E. Approximately 45 times square root of 3 feet. The correct answer is E. The pine tree is approximately 45 times square root of 3 feet tall. Step 1. Let's draw the figure as described in the question. Our drawing need not be realistic. All we want to do is to be able to express the problem by way of a trigonometric triangle, so a sketch of a triangle will suffice. Step 2. Determine known values. We know that we are dealing with a right triangle with one of its other angles measuring approximately 60 degrees. The 45-foot horizontal distance from the base of the pine tree to where Jeremy is standing is the adjacent side of our triangle. The unknown height, h, of the pine tree is the opposite side of our triangle. So what trigonometric ratio should we use in the given scenario? Since we are dealing with the opposite and adjacent sides, we can use either tangent or cotangent. Let's use tangent. Tangent 60 degrees is equal to the unknown height, h, over the horizontal distance of 45 feet. From here we can solve for h. Take note that since we are dealing with a 60-degree right triangle, the ratio of its sides can be simplified or reduced to 1, square root of 3, and 2, for the adjacent side, opposite side, and hypotenuse, respectively, regardless of their actual measurements. We can therefore replace tangent 60 degrees in our equation with square root of 3 over 1, or simply square root of 3. Therefore, the pine tree is approximately 45 times square root of tree feet.
Drill question number 6. The triangle in the figure is a right triangle with one of its angles measuring 45 degrees. Which of the following is, or are, true? 1. The triangle is an isosceles triangle. 2. The third angle measures 45 degrees. 3. Two of its sides are equal in length. 4. If the third angle is beta, tangent beta is equal to cotangent 45 degrees. 5. The hypotenuse measures square root of 2 units. Your answer choices are: A. All 5 statements are true. B. 1, 3, and 5 only. C. 4 only. D. 2, 3, and 4 only. E. None of the statements is true. The correct answer is A. All of the 5 given statements are true. Let's evaluate each of the given statements. Statement 1. The triangle is an isosceles triangle. Recall that the inner angles of any triangle sum up to 180 degrees. Since we have a right triangle whose one other angle is 45 degrees, then the third angle is also 45 degrees, that is, 180 minus 90 minus 45 equals 45. A triangle with 2 angles being equal is necessarily an isosceles triangle. In this particular case, it is an isosceles right triangle. Statement 1 is true. Statement 2. The third angle measures 45 degrees. We already established this to be true from statement 1, so yes, this is also true. Statement 3. 2 of its sides are equal in length. We've established from statements 1 and 2 that our given triangle is an isosceles triangle. By definition, an isosceles triangle is a triangle having 2 sides of equal length. So yes, statement 3 is also true. Statement 4. If the third angle is beta, then tangent beta equals cotangent 45 degrees. We've already established in statement 1 that the third angle is 45 degrees. Hence, beta equals 45 degrees, and statement 4 effectively becomes tangent 45 degrees equals cotangent 45 degrees. We've also already established that our triangle is an isosceles triangle with 2 of its sides being equal in length. From the figure, the opposite side is 1. Therefore, the adjacent side is also 1. From sohcahtoa, tangent is opposite over adjacent. Hence, tangent 45 degrees is 1 over 1, or simply 1. Cotangent is adjacent over opposite. Hence, cotangent 45 degrees is also 1 over 1, or simply 1. So yes, statement 4 is also true. Statement 5. The hypotenuse measures square root of 2 units. The 2 sides both measure 1 unit each. Using Pythagorean formula, the hypotenuse should be equal to the square root of the quantity 1 squared plus 1 squared, or the square root of 2. Yes, statement 5 is also true. So in the end we have established that all 5 statements are true.
Drill question number 7. A 20-foot beam leans against a wall. The beam reaches the wall 13.9 feet above the ground. What is the measure of the angle formed by the beam and the ground? A. 44 degrees. B. 48 degrees. C. 55 degrees. D. 60 degrees. E. 62.5 degrees. The correct answer is A. 44 degrees. This question is modeled on an actual question that appeared in a University of the Philippines College Admission Test or UPCAT. Tip: it is always recommended to draw the figure described for a better visualization and appreciation of the problem. We made the sketch for you, as shown. Note: it should be safe to assume that the wall is perpendicular to the ground. From the resulting right triangle, we can derive the following values. The length of the hypotenuse is 20 feet. The length of the opposite side is 13.9 feet. Let theta be the angle formed between the beam and the ground. We are solving for theta. Applying our sohcahtoa rule, we can compute for sine theta as shown. From our computed value of sine theta, we can compute for theta to be 44 degrees. Important note: in most math proficiency exams, calculators are not allowed. Applicable trigonometric tables are usually provided for problems involving trigonometry, such as this one. In the case of our given problem, we compute for 13.9 over 20 and get 0.695. We then locate 0.695 under the sine table of the trigonometric tables provided. We should get 44.03 degrees.
Drill question number 8. The figure shows a right triangle with theta as one of its acute angles. Which of the following is true? A. Secant theta equals 3 times square root of 7 over 4. B. Cosine theta equals 3 times square root of 7 over 4. C. Tangent theta equals 3 times square root of 7 over 4. D. Sine theta equals 3 over 4. E. Cotangent theta equals 3 over square root of 7. The correct answer is E. Cotangent theta equals 3 over square root of 7. For us to find the trigonometric ratios of the given triangle, we first need to find the length of the opposite side, which is not given in the figure. Let's call it x. Using Pythagorean formula, x should be equal to the square root of the quantity 12 squared plus 9 squared. Therefore, x equals square root of 63. But wait. If the length of the opposite side is square root of 63, where did the square root of 7, or 3 times square root of 7, in the answer choices come from? Square root of 63 is actually equal to 3 times square root of 7. We can show it in this form by factoring 12 squared minus 9 squared, instead of simply calculating it outright, as shown. Now let's evaluate each of the answer choices. Answer choice A. Secant theta equals 3 times square root of 7 over 4. Referring to our triangle and using sohcahtoa, secant theta should be equal to 12 over 9 or 4 over 3, not 3 times square root of 7 over 4. We eliminate A. Answer choice B. Cosecant theta equals 3 times square root of 7 over 4. Again, referring to our triangle and using sohcahtoa, cosecant theta should be equal to 12 over 3 times square root of 7, or 4 over square root of 7, not 3 times square root of 7 over 4. We eliminate B. Answer choice C. Tangent theta equals 3 times square root of 7 over 4. From sohcahtoa, tangent is opposite over adjacent. Hence, tangent theta should be 3 times square root of 7 over 9, or square root of 7 over 3, not 3 times square root of 7 over 4. We eliminate C. Answer choice D. Sine theta equals 3/4. From sohcahtoa, sine is opposite over hypotenuse. Sine theta should be 3 square root of 7 over 12, or square root of 7 over 4, not 3 over 4. We also eliminate E. Answer choice E. Cotangent theta equals 3 over square root of 7. From sohcahtoa, cotangent is adjacent over opposite. Thus, cotangent theta should be equal to 9 over 3 times square root of 7, or 3 over square root of 7. This is the correct answer.
Drill question number 9. If angle theta is in the fourth quadrant, which of the following is always true? A. Secant theta over cosecant theta is greater than 0. B. Cotangent theta equals 0. C. Sine theta times cosine theta is less than 0. D. Sine theta is less than tangent theta. E. Tangent theta is greater than 0. The correct answer is C. Sine theta times cosine theta is less than 0. This question is modeled on an actual question that appeared in the Ateneo de Manila College Admission Test or the ASET. To correctly answer this question, we need to do a quick sketch of theta being on the fourth quadrant of the Cartesian plane. By doing so, we can quickly establish that the adjacent side is positive while the opposite side is negative. Take note that by Pythagorean formula, the hypotenuse is always positive regardless of the signs of the opposite and adjacent sides. In other words, the hypotenuse is positive in any quadrant of the Cartesian plane. Next, we quickly find the values of our trigonometric ratios using the sohcahtoa rule, as follows. Sine theta is negative over positive, so it is negative. Its reciprocal ratio cosecant should also be negative. Cosine theta is positive over positive, so it is positive. Its reciprocal ratio secant should also be positive. Tangent theta is negative over positive, so it is negative. Its reciprocal ratio cotangent should also be negative. Now let's evaluate each of the given answer choices based on these findings. Answer choice A, secant theta over cosecant theta is greater than 0. Secant is positive while cosecant is negative. Positive over negative will result to negative. Therefore secant theta over cosecant theta is less than, not more than, 0. We can eliminate answer choice A. Answer choice B, cotangent theta equals 0. We've already established earlier that cotangent theta is negative, so it is not equal to 0. We can eliminate answer choice B. Answer choice C, sine theta times cosine theta is less than 0. Sine theta is negative and cosine theta is positive. Negative times positive is negative and, therefore, less than 1. Answer choice C is true, so this must be our correct answer. When taking your actual test, you may stop here and proceed to the next question. But for this drill, let's go ahead and evaluate the rest of the answer choices. Answer choice D, sine theta is less than tangent theta. Both sine and tangent are negative, but having no actual numbers for the lengths of the sides of our triangle, we cannot establish whether sine or tangent is more or less than the other. We can eliminate this answer choice. And finally, answer choice E. Tangent theta is greater than 0. Tangent theta is negative, so it is less, not greater, than 0. We can also eliminate answer choice E.
Drill question number 10. In which quadrant is tangent less than 0, and cosecant is greater than 0? A. Quadrant 1. B. Quadrant 2. C. Quadrant 3. D. Quadrant 4. E. A tangent that is less than 0, and a cosecant that is greater than 0, cannot coexist in the same quadrant. The correct answer is B. Quadrant 2. This question is modeled on an actual question that appeared on an SAT mathematics exam. Let us find the values of tangent and cosecant in each of the quadrants of the Cartesian plane. Recall from sohcahtoa that tangent is opposite over adjacent, while cosecant is hypotenuse over opposite. Recall also that from Pythagorean formula, the hypotenuse is always positive, regardless of where it is in the Cartesian plane. In quadrant 1, both tangent and cosecant are positive, so they are both greater than 0. We can eliminate A. In quadrant 2, tangent is negative while cosecant is positive. Therefore, tangent is less than 0, and cosecant is greater than 0. This satisfies the conditions in our given question. So B is the correct answer. In your actual exam you may choose B and proceed to the next question. But for this drill, let's go ahead and evaluate the remaining answer choices, to validate that B is indeed the correct, and the only correct answer. In quadrant 3, tangent is positive, since both opposite and adjacent sides are negative. Cosecant, on the other hand, is negative. Hence, tangent is greater than 0 while cosecant is less than 0. This are the opposites of the conditions we are looking for. We can eliminate C. In quadrant 4, tangent is negative, that is, less than 0, and cosecant is also negative, also less than 0. We can also eliminate D. Answer choice E suggests that the given conditions cannot coexist in any of the quadrants. We've already established this to be not true, since the given conditions were met in quadrant 2.
Drill question number 11. Which of the following is equal to cosecant 1550 degrees? A. Tangent 20 degrees. B. Minus cosecant 70 degrees. C. Minus cosecant 20 degrees. D. Secant 70 degrees. E. Secant 20 degrees. The correct answer is E. Secant 20 degrees. This is another question that is modeled on an actual question that appeared in a previous set. To correctly answer this question, we will need more than our basic trigonometric ratios. We will need two related geometric and trigonometric concepts, namely, coterminal angles and reference angles. So let's do a quick refresher on coterminal angles and reference angles, shall we? Coterminal angles are angles in standard position, that is, angles with the initial side on the positive x-axis, that have a common terminal side. For example, the angles 30 degrees, minus 330 degrees and 390 degrees are all coterminal. And how do we determine the coterminal angle of a given angle? The simplest and fastest way to find the coterminal angle of any given angle is to divide that angle by 360. From the resulting quotient with remainder, the remainder is our coterminal angle. And what about reference angle? The reference angle is the smallest possible angle made by the terminal side of the given angle with the x-axis. It is always an acute angle, except when it is exactly 90 degrees. A reference angle is always positive irrespective of which side of the axis it is falling. The simplest and fastest way to find the reference angle of any given angle is to remember these simple formulas. If given angle is between 0 and 90 degrees, that is, in the first quadrant, the reference angle is the given angle itself. If given angle is between 90 and 180 degrees, that is, in the second quadrant, reference angle equals 180 minus the given angle. If given angle is between 180 and 270 degrees, that is, in the third quadrant, reference angle equals the given angle minus 180. If given angle is between 270 and 360 degrees, that is, in the fourth quadrant, reference angle equals 360 minus the given angle. Okay, now back to our given problem. Step 1. Find the coterminal angle of 1550 degrees. We divide 1550 by 360, which will give us 4 remainder 110. Hence our coterminal angle is 110 degrees. Step 2. Find the reference angle of 110 degrees. 110 degrees is between 90 and 180 degrees. Thus, its reference angle is equal to 180 minus 110, or 70 degrees. Step 3 is to draw our resulting trigonometric triangle, as shown. Take note that the complementary angle of 70 degrees is 20 degrees. Let's include that in our drawing as well, since some of our answer choices are based on this angle. Let's also label the sides of our resulting right triangle as x, y, and z, as shown. Step 4. Now we can proceed to evaluate cosecant 1550 degrees, which is essentially the same as cosecant of its reference angle 70 degrees. From our sohcahtoa rule, sine 70 degrees is equal to y over z. Cosecant 70 degrees is simply the reciprocal of sine 70 degrees, or z over y. Now let's evaluate each of the given answer choices. Answer choice A, tangent 20 degrees. Referring to our triangle and using sohcahtoa, tangent 20 degrees is x over y, so no, it is not equal to cosecant 70 degrees. Answer choice B, minus cosecant 70 degrees. Since we've established cosecant 70 degrees to be z over y, minus cosecant 70 degrees should be minus z over y. Obviously they are not equal. Answer choice C, minus cosecant 20 degrees. From our triangle, minus cosecant 20 degrees should be minus z over x. Also not equal to cosecant 70 degrees. Answer choice D, secant 70 degrees. Secant 70 degrees should be z over x. It is not equal to z over y, so not equal to cosecant 70 degrees. And finally, answer choice E, secant 20 degrees. Secant 20 degrees should be z over y. This is equal to cosecant 70 degrees and therefore, our correct answer.
To wrap up our mathematics proficiency drill on trigonometric ratios, here are some takeaways for you. 1. The trigonometric ratios relate the angles in a right triangle to the ratios of the sides. Take note that trigonometric ratios are only used with right triangles. 2. There are 6 trigonometric ratios: sine, cosine, tangent, cosecant, secant, and cotangent. You only need to memorize the first 3, sine, cosine, and tangent. The other 3, cosecant, secant, and cotangent, are simply reciprocals of the first 3. 3. Sine and cosine are always less than 1 because the hypotenuse is always their denominator. It follows that cosecant and secant are always greater than 1 since they are simply reciprocals of sine and cosine, respectively, and the hypotenuse is always their numerator. Tangent and cotangent can be less than, equal to, or greater than 1. 4. Use the sohcahtoa rule to quickly find any of the trigonometric ratios. Just by remembering sohcahtoa, you should never again forget any of your trigonometric ratios. And 5. Regardless of the actual lengths of their sides, the sides of 30-degree, 45-degree, and 60-degree right triangles can be reduced to the following values as shown. Memorize these 3 triangles and the values of their respective sides. You can thank us for it later. If you wish to learn more about trigonometric ratios, you may check out some links that we have included in the description below.
You have just watched Review Central's Mathematics Proficiency Reviewer Drills, featuring drill questions on trigonometric ratios. By now you should be ready to take on any mathematics proficiency test featuring trigonometric ratios. The drill questions we featured in this particular episode have been carefully curated to present to you as many of the typical trigonometric ratio questions that appear on mathematics exams. If you wish to watch more Mathematics Proficiency Reviewer Drills, check out our Mathematics Proficiency Reviewer Drills playlist. Check out also our other reviewer drill playlists for other topics. If you haven't done so yet, please don't forget to subscribe to Review Central, and click or press the bell button to make sure you get notified whenever we post a new reviewer or other review materials on this channel. Please like if you find this video useful and feel free to share to anyone who may also benefit from it. We wish you all the best on your forthcoming exam.